Alright, welcome back to the channel. In this video, we're going to be focusing on OWASP API Security Top 10 Part 2. If you missed Part 1, go ahead and check that out. It'll be listed on my page. Let's get started with the launching the Kali Linux machine as well as the VM that we're going to be using and or attacking. Task 1, quick recap. In the previous room, we studied the first 5 principles of OWASP API Security. Now in this room, we'll briefly discuss the remaining principles and their potential impact and mitigation measures. Learning objectives are as following: identification of security misconfigurations, preventing denial of service, DOS, DDoS, against the API, and ensuring appropriate logging and monitoring of users and or data. Learning prerequisites are as following: an understanding of the following topics is recommended before starting the room: how websites work, HTTP protocols and methods, principles of security, and OWASP Top 10 vulnerabilities. And this is why we went through the small room on OWASP Top 10, also listed on the channel. Go ahead and take a look at that if you need. We've connected to our machine, and just as the other room, it's actually going to launch it already for us, as well as launch Talent API Tester. So we don't need to do this. And I can connect and log into the machine. We've done that. Let's click complete. Move on to task 2, vulnerability. What is that? 6, 7, 8, 9, 10. Yeah, 6, mass assignment. So let's move on to task 2, vulnerability 6, mass assignment. How does this happen? Mass assignment reflects a scenario where client-side data is automatically bound with server-side objects or class variables. However, hackers exploit the feature by first understanding the application's business logic and sending specifically crafted data to the server, acquiring administrative access, or inserting tampered data. This functionality is widely exploited in the latest frameworks like Laravel, CodeIgniter, and etc. Consider a user's profiles dashboard where users can update their profile like associated email, name, address, and etc. The username of the user is a read-only attribute and cannot be changed. However, a malicious actor can edit the username and submit the form. If necessary filtration is not enabled on the server-side model, it will simply insert and or update the data in the database. Likely impact of this scenario. The attack may result in data tampering and privilege escalation, which we love over here, from a regular user to administrator. Practical example. Open the VM, you'll find that the Chrome browser and Talent API Tester application are running automatically, which we'll be using for debugging the API endpoints. Bob has been assigned to develop a sign-up API endpoint, API rule 6/user, that will take a name, username, and password as input parameters in post requests. The user table has a credit column with the default value of 50. Users will upgrade their membership to have a larger credit value. You can see the issue here already. If you're using an e-commerce site or any site that's going to allow you to purchase things with credit, this is a possible issue. Bob has successfully designed the form and used the mass assignment feature in Laravel to stop all incoming data from the client side to the database as shown below. So we have a vulnerable form here in the API Talent post request to localhost 80 MHT, which is the company, API rule 6/user. We're going to be searching for name, username, password, and or amount of credits. Response 201 is created. Bob, username Bob MHT, credit 110, ID 3. What's the problem here? Bob is not doing any filtering on the server side. Since using the mass assignment feature, he is also inserting credit values in the database. Malicious actors can update the value. We could put 1,000,000 here if we choose. The solution to the problem is pretty simple. Bob must ensure necessary filtering on the server side, API rule 6, user_secure. and ensure that the default value of credit should be inserted as 50, even if more than 50 is received from the client side, as shown below with the 110, right? Response 201 created, Bob MHT, credit 50. Mitigation measures. Before using any framework, one must study how the backend insertions. Before using any framework, one must study how the back insertions and updates are carried out. In the Laravel framework, fillable and guarded arrays mitigate the above mentioned scenario. So if we take a look at fillable and guarded inserts, of course, when using Eloquent, we don't only need to retrieve models from the database, we need to insert new records. Thankfully, Eloquent makes it simple. To insert a new record in the database, you should instantiate a new model instance and set attributes on the model. Then call the save method on the model instance. So here, name, use app controller, flight, use illuminate, HTTP request, change flight controller, extends controller, here's parameters here, request, response, public function storing request, and then it's going to validate the request by checking flight. Flight equal to name, request of the name of the user, and saving the flight information. That way this cannot happen. We cannot overwrite what's already been written, essentially. In this example, we assign the name field from the incoming HTTP request to the name attribute of the app model's flight model instance. When we call the save method, a record will be inserted into the database. The models created at and updated at timestamps will automatically be set when the save method is called, so there's no need to set them manually like I just said. We could continue reading this, but you get the idea. Mitigation measure 2. Avoid using functions that bind an input from a client to code variables automatically. Essentially, this is having no checks in here. Third mitigation measure, allow list those properties only that need to get updated from the client side. Everything else will be stopped. Answer the questions below. Is it good practice to blindly insert and or update user provided data in the database? The answer is no. Question 2, using API rule 6, user underscore secure, insert a record in the database using credit value as 1,000. So let's go ahead and change this API rule here in the Talent API to 6. Get rid of underscore V. User is going to be secure. User underscore S. And if we send this now, it's not going to work. We need to change this to a post request. We need to add parameters. Name, username, password, credit. Name, username, password, amount of credit. Question is, the record name is creating is 1,000. So I believe we need to basically use the same guy here, Bob. Bob underscore MHT. Password, it really wouldn't hurt to use the same password. And again, we're going to have to save this in a different fashion, as it's hard to copy paste, and I don't really even remember how to copy paste into the VM because there's no option. So in order to save time, just write it in a note in your specific VM. If you're using the attack box, you'll have the clipboard, so you won't have to worry about this. Go over here, then we'll launch it again, and we're gonna have to type it in because, like I said, you can't copy paste. So pound GE star by capital A 35 U6 35 capital U6 pound. Okay. 2 pounds. Whoops. And credit, right? They want us to do 1,000. Let's just do 110 first, just to see the response. As you can see, Bob MHT, credit 50, ID 5. Now, we're using the secure version, right? So it's automatically parsing our information, and as already explained, it's not going to allow us to type any value here, and whatever value we type here is not going to matter. It's just going to give us 50 credits anyway. Send again. Same thing, ID 6. Now, if we could do, I don't know, 5,000, right? Is this ID incrementing? No. It is. The ID is changing, incrementing, but it really doesn't matter. That parameter is pretty much not useful in this case, but you get the idea. The credit will not change from 50. Go ahead and click complete. What would be returned credit value after performing question number 2? The answer is 50. Now, if we were to go to user underscore V real quick, it's not going to like this. User V, because it's just user. As you can see, this is the vulnerable portion here. We have 5,000 credits. So, and then go back to user underscore S, send again. We have 50 credits. This is the real number. Okay, so there you go. Let's move on to task 3, vulnerability, the 6, 7. All right, let's move on to task 3, vulnerability 7, security misconfiguration. Security misconfiguration. How does this happen? Security misconfiguration depicts an implementation of incorrect and poorly configured security controls that put the security of the whole API at stake. Several factors can result in security misconfiguration, including proper and/or incomplete default configuration, publicly accessible cloud storage, cross-origin resource sharing (CORS), and error messages displayed with sensitive data. Intruders can take advantage of these misconfigurations to perform detailed reconnaissance and get unauthorized access to the system. Security misconfigurations are usually detected by vulnerability scanners or auditing tools, and thus can be curtailed at the initial level. API documentation, a list of endpoints, error logs, and etc. must not be publicly accessible to ensure safety against security misconfigurations. Typically, companies deploy security controls like web application firewalls, which are not configured to block undesired requests and attacks. Likely impact. Security misconfiguration can give intruders complete knowledge of API components. Firstly, it allows intruders to bypass security mechanisms. Stack trace or other detailed errors can provide the malicious actor access to confidential data and essential system details, further aiding the intruder in profiling the system and gaining entry. Practical example is here. Continue to use the Chrome browser and Talent API tester for debugging in the VM. Example 2, the company MHT is facing serious server availability issues. Therefore, they assigned Bob to develop an API endpoint, API rule 7/ping v get request that will share details regarding server health and status. Bob successfully designed the endpoint. However, he forgot to implement any error handling to avoid any information leakage. This is going to be the vulnerable depiction here. API rule 7 ping v. Let's change this in our Talon before moving forward. API 7 ping underscore vulnerable, and change our method or our request to get. We'll go ahead and run it as well, because why not? So here you can see we've been returned a string. Now we are provided with a path to the C drive. They're using XAMPP. Some information there, even though it's not highlighted necessarily in this, but it's beyond the scope, but whatever. MHT, vendor, Laravel framework. At this point, right, what a good hacker would do is say, hey, they're using Laravel. Can we find which version they're using? Is there a CVE associated with this so I can start attacking this API, essentially? And then we also see C drive, XAMPP, I mentioned previously, HT docs, MHT, vendor, Laravel framework, blah, blah, blah. Now we have a path to the controller. What's the issue here? In case of an unsuccessful call, the server sends a complete stack trace in a response containing function names, controller, and route information, as I just mentioned, file path, and etc. An attacker can use information for profiling and preparing specific attacks on the environment. The solution to the issue is pretty simple. Bob will create an API endpoint, API rule 7, ping secure, that will carry out error handling and only share desired information with the user, as shown here in the secure version. We just switch this to ping s. "500 internal server error, success false. Message, network server at 2 malfunctioned, error number, please contact admin support." Essentially removing all information we could use to do more recon on this API. Mitigation measures. Limit access to the administrative interfaces for authorized users and disable them for other users. Number 2, disable default usernames and password for public-facing devices. That would be routers, web application firewalls, and etc. Number 3 would be disable directory listing and set proper permissions for every file and folder. And last but not least, remove unnecessary pieces of code snippets, error logs, and etc., and turn off debugging while the code is in production. Answer the questions below. Is it an excellent approach to show error logs from the stack trace to general visitors? The answer is no. Try to use the API call, API rule 7, ping s, and the attached VM. We've done that. What is the HTTP response code? When we do it in 7, I believe it was 502, but we're going to check again just because. API rule 7, ping rule. It's 500 here. Never mind. Answer is 500. What is the error ID number in the HTTP response message? That's 1401, error ID. All right, let's move on to task 4, vulnerability 8, injection. How does this happen? Injection attacks are probably among the oldest API and web-based attacks that are still being carried out by hackers on real-world applications. Injection flaws occur when user input is not filtered and directly processed by an API, thus enabling the attacker to perform unintended API actions without authorization. An injection may come from structured query language, SQL, operating systems, OS commands, which we've gone over that in the previous videos. Extensible markup language, XML, and nowadays frameworks offer functionality to protect against this attack through automatic sanitation of data. However, applications built in custom frameworks like core PHP are still susceptible to such attacks. And essentially, a lot of companies also use proprietary software, and that would fall under the being vulnerable to such attacks as well. Likely impact. Injection flaws may lead to information disclosure, data loss, DDoS, and complete account takeover. The successful injection attacks may cause intruders to access the sensitive data or even create new functionality and perform remote code execution. Essentially get a shell on the machine and then own them. Practical example. Continue to use the Chrome browser and Talent API tester for debugging in the VM. Few users of company MHT reported that their account password had changed and they could not further log into their original account. Consequently, the dev team found that Bob had developed a vulnerable login API endpoint, API rule 8/user/login vulnerable, that is not filtering user input. Well, this is an easy one. A malicious attacker requires the username of the target, and for the password, they can use the payload or 1 is equal to 1. And get an authorization key for any account as shown below. So we'll go API rule 8, user underscore V. And it's a post request, so we'll password username. So we'll go change this. And I believe keep it in the body. You'll remove name, remove credit. We'll change this username to admin. Password 1 is equal to 1 dash dash slash slash dash dash. Send it. Pretty sure we don't need a space there. Or doesn't like something here. Password, username. Oh, it's login V. Whoops. So essentially, this is mimicking a login page here, even though you're not going to be seeing one. So login, directory of user, login v, send that. We get 200 response OK. See true, and we get the auth key here for the user. Copy that. Bob immediately realized his mistake. He updated the API endpoint to API rule 8 user login underscore secure and used parameterized queries and built-in filters of Laravel to sanitize user input. As a result, all malicious payloads on username and password parameters were effectively mitigated, as shown here. So if we do this in the login of secure, change the V to an S, send 403 forbidden. And here, like on a login page, you'll see incorrect username or password instead of a key. And if we try to put any other SQL injection in here, it's not going to work. Mitigation measures. Ensure to use a well-known library for client-side input validation. 2, if a framework is not used, all client-provided data must be validated first and then filtered and sanitized. 3, add necessary security rules to the web application firewall. Most of the time, injection flaws can be mitigated at the network level. 4, make use of built-in filters and frameworks like Laravel, CodeIgniter, and etc. to validate and filter data. Let's answer the questions here. Can injection attacks be carried out to extract data from the database? The answer is yeah. Question 2, can injection attacks result in remote code execution? The answer is yes, as we were discussing before. Question 3, what is the HTTP response code if a user enters an invalid username or password? 403. Let's move on to task 5, vulnerability 9, improper asset management. All right, task 5, vulnerability 9, improper asset management. How does this happen? Inappropriate asset management refers to a scenario where we have two versions of an API available on our system. Let's name API v1 and API v2. Everything is wholly switched to API v2, but the previous version API v1 has not been deleted yet. Considering this, one might easily guess that the older version of the API, i.e. APv1, doesn't have the updated or latest security features. Plenty of other obsolete features of API v1 make it possible to find vulnerable scenarios, which may lead to data leakage and server takeover via a shared database amongst API versions. Is essentially about non-properly tracking API endpoints. The potential reason could be incomplete API documentation or absence of compliance with the software development lifecycle. A properly maintained, up-to-date API inventory and proper documentation are more critical than hardware-based security control for an organization. Likely impact. The older or the unpatched API versions can allow the intruders to get unauthorized access to confidential data or even complete control of the system. Practical example as follows. Continue to use Chrome browser and Talend API tester for debugging in the VM. During API development, company MHT has developed different API versions like v1 and v2. The company ensured to use the latest versions of API calls but forgot to remove the older version from the server. Consequently, it was found that old API calls like API Rule 9 v1 user login return more information like balance, addresses, and etc. against the user. So let's go ahead and change this to API Rule 9 v1. API 9. Get rid of this. v1 user login. Okay, we're going to do a post request. Probably gonna username password Alice. Change the username to Alice. Password is going to be ## exclamation at ##. Oh, that's money. ## exclamation at # exclamation exclamation. Okay, send that request. So the V1 version is showing username of Alice, the balance of 100, country USA. Okay. Bob, being the developer of the endpoint, realized that he must immediately deactivate old and unused assets so that users can only access limited and desired information from the new endpoint. V2 user login is shown below. So here we can see, without running the post request, that the balance and the country origin of Alice has been removed or sanitized. Mitigation measures. Access to previously developed sensitive and deprecated API calls must be blocked at the network level. APIs developed for R&D, QA, production, and etc. must be segregated and hosted on separate servers. Ensure documentation of all API aspects, including authentication, redirects, errors, CORS policy, and rate limiting. And last but not least, adopt open standards to generate documentation automatically. Is it a good practice? These are the questions. Is it a good practice to host all APIs on the same server? No. Make an API call to API Rule 9, V1 user login with using the username Alice and password. We've done that. What is the amount of balance associated with Alice? She's got $100. What is the country? USA. And that is pretty much it for improper asset management. And essentially having different asset or different API servers, right, for R&D or QA, is pretty much going to take care of scrubbing this information for us, even though it's really not being shown here. Anyway, let's move on to task 6, vulnerability 10, insufficient logging and monitoring. How does it happen? Insufficient logging and monitoring reflects a scenario where an attacker conducts malicious activity on your server. However, when you try to track the hacker, there is not enough evidence available due to the absence of logging and monitoring mechanisms. Several organizations only focus on infrastructure logging like network events or server logging, but lack API logging and monitoring. Information like visitors' IP address, endpoints access, input data, and etc., along with the timestamp, enables the identification of threat attack patterns. If logging mechanisms are not in place, it would be challenging to identify the attacker and their details. Nowadays, the latest web frameworks can automatically log requests at different levels like error, debug, info, and etc. These errors can be logged in a database or file or even passed to the SIEM solution for detailed analysis. Likely impact. Inability to identify attacker or hacker beyond the attack. And practical example, API Rule 10 logging. Let's go ahead and change that. Yeah, get requested. Hi. Okay, so when we run it, we get response 200. An abnormal activity has been detected. Your IP address is 127.0.0.1. Shows us that we're using Mozilla, Windows NT, 10.0, Apple WebKit, timestamp. Later, it was also decided that this is the same thing we just did. Later, it was also decided that same would be forwarded to a SIEM solution for correlation and analysis. Mitigation measures. Ensure use of the security information and event management SIEM system for log management. 2. Keep track of all denied accesses, failed authentication attempts, and input validation errors using a format imported by SIEM and enough detail to identify the intruder. Mitigation measure 3. Handle logs as sensitive data and ensure their integrity at rest and transit. Moreover, implement custom alerts to detect suspicious activities as well. Answer the questions below. Should the API logs be publicly accessible so that the attacker must know they are being logged? No, we don't want them to know. What is the HTTP response code in case of successful logging of user information? That would be 200. And task 7, conclusion. Phew, that was simple. It would be correct to say that over half of OWASP API Security's top 10 list is relevant to authorization and authentication. Most commonly, API systems are hacked because of failure in authorization and authentication mechanisms and security misconfigurations. In a nutshell, API developers must safeguard APIs in line with best cybersecurity practices. The modules like sign-in, role-based access, user profile settings, and etc. must be given more importance as malicious actors tend to target known endpoints for gaining access to the system. Stay tuned and keep developing secure APIs. Answer the question below. I have completed the room, and congratulations. We have finished the OWASP Top 10 API Part 2. Thank you for watching. Please drop a comment, like, and subscribe for more.